In this video, we'll be covering about recursion and the idea behind recursion. I would not like to start with the definition first, but with a story. Let's say you are a student and you need a sign from the principal for your leave letter. You go to the principal's office, but the principal says, first get an approval from the HOD. You go to the HOD, but the HOD says, first get approval from your class teacher. And finally, the class teacher signs it. The signed paper goes back to the HOD. The HOD approves it and returns the signed form to the principal where the principal signs it. And this is our desired result. So what is happening here? Is this anywhere related to recursion? Yes, this is exactly how recursion works. When a function doesn't know the answer, it immediately calls the smaller version of the problem, and that is the definition. Function calling itself to solve a smaller version of the same problem. As we can see, sign is the function here, and principal, HOD, class teacher are the input parameters. Before we move on, I would like to discuss some basic terms. And the first term I'm going to take is the base case. The base case is the condition where the function stops calling. And it is very, very important because it avoids infinite looping. Let me state here that after class teacher, we can see that it is not calling any other function and it is starting to return to the higher level functions. And the next thing I'm going to talk about is call stack. Call stack is a memory structure that keeps track of who is waiting for an answer or an approval. Now, let me model this here. So let's say this is our call stack. And the first function is sign off principal. So we'll be putting it here. I'm using shortcuts, so just in case, letting you know. And after this, we call the HOD function. I'm sorry, the sign function and the input parameter is HOD. And then we call the class teacher function. We can see that once the class teacher function is called, it is returning the signed form. So once it returns the signed form, we'll be removing, and we can see that the one which was added in last was removed first. We've seen this somewhere, right? The basic principle of stack, LIFO, last in, first out. And this is how the call stack operates. So this goes back and the sign of HOD returns the sign form. So we remove it here, and after this function works and we got a sign form and we remove it here. Okay, we got a blank screen staring at us. I'll be coding a simple recursive function to help you understand what is going on. So the basic import statement here and the class which happens to be recursion, since I have the file name as recursion.java, and that's it. So now we'll be calling our recursive function, which is this. By the way, our recursive function is just gonna print from 1 to 5. Okay, and now I need to define this function. Sorry. And since we know that recursion just calls itself, the calls a function itself, we'll be calling with just the parameter changed, and we'll be printing to see what it is printing, right? Sorry. Okay, so far so good, right? So when we execute this, right, no compilation error, and when we execute this, something weird happens. You can see that there is a stack overflow error. That is, the stack memory overflows. It got filled up and it has no space to process the next function. So this is a problem, right? How do we solve this? And this is where the base case comes in. Now I told you that I want to print from 1 to 5. So I need to make sure that if it goes less than 1, I need it to return. right? And what happens is once n becomes less than 1, it returns. That is, this is the lowest level this function could go. Now let us try running it. I'll be clearing this, and I'm sorry. And if we run this, we can see that it is printing correctly. Now, how does the call stack look in this situation? We'll be seeing it here. Wait. So I'm just using the print statement. 1 second. Yeah. Now, if you see carefully, see the higher level function is being called first, and once the lower level function comes, it starts returning. See, this is the bottom up approach of recursion. There's a top down approach also, and we'll be covering that up in the next video.